Now I want to talk about web application attacks. And there's a lot of different ones out there, but some of the common ones are SQL injection, cross-site scripting, and indirect object or insecure direct object references. So there's a system out there, DVWA, which stands for Damn Vulnerable Web Application. That is installed by default on Metasploitable 2. So as long as you have that Metasploitable 2 VM, it will automatically have DVWA. And so that is it's a PHP with MySQL application, which has different difficulty levels that you can set it for, low, medium, or high, for each vulnerability. And so you can exploit it, and you can change the difficulty level to see how various security methods end up securing against some of the more trivial type of exploits. There's OWASP Juice Shop, which is it's a modern realistic e-commerce shop, which is written in Node.js, Angular, and there's a lot of built-in challenges mapped to the OWASP top 10. Has a built-in scoreboard, it's gamified, it's actually quite a lot of fun. And then you can run these locally in a lab. Like I said, Metasploitable 2 has DVWA running on it, so we'll be testing the SQL injection against that particular virtual machine. So, SQL injection, how does it work? And again, a lot of you are familiar with this, and there is that famous XKCD comic, the Little Bobby Tables comic there, where the student, his name ended in drop tables students. I think it was drop table students. But SQL injection is basically where you trust that the user is not trying to do anything malicious. Well, as we all know, users tend to try to break things, sometimes on purpose, sometimes on accident. So, for example, on an intended query, you might want to grab the first name and last name from the user's table where the user ID equals whatever that ID the user specified. Well, an attacker, if that's what you're doing and it seems reasonable, the attacker can send a single quote or, which is a logical or, and then you can put these in quotes, or you don't necessarily have to put it in quotes. It could be 1 equals 1, and then you can end it with a double dash and a space. And so if you do that, you can see kind of that second line there, where it's looking for the user ID is equal to nothing, or 1 is equal to 1, which is true. So then it will return every row in that particular table. So it happens because the user input is just passed directly into that ID variable, and it is passed directly into the SQL query, and it's not actually sanitized. So this is why you should always sanitize your inputs. And you can do almost anything with this. There's authentication bypass, you can dump entire tables, you can read files, you can execute operating system commands, all sorts of stuff. And I will say that DVWA, you can do quite a lot of stuff with just that little quote or 1 equals 1 and then a double dash after that. So some payload examples, there's the 1 or 1 equals 1 that we just talked about. If you want to extract the database version, and that's information leakage. So if you know the version of the database, then you might have other exploits you can run against that or other vulnerabilities. So in this case, it's the same 1, and then you're unioning, selecting from the version with null, and then the double dash, and then this is one of the things which is a little unclear when I first saw it. There's a single dash at the end of this. That's not required. What is required is that double dash at the end and then another character. So if you just type out 1 union select at version, comma, null, space, dash, dash, and then pass that in there, this isn't going to work. But if you do a dash, dash, space at the end, it will. So that's why sometimes you will see an extra dash at the end to give it that extra white space that is needed for this particular command. I will also say that this one to get the version. And if you're unfamiliar with SQL, well, this is a perfect opportunity to learn more about SQL and explore it more. But whatever your output is going to be, it has to match that number of fields. So I mentioned this for the like the SQL injection, the first one that you'll end up having to do. If you want to get the version, well, there are 5 fields. And so what you would end up needing to do is unioning it, because they all have to match up with those number of fields. And the order of the nulls and the ADAT version will be dependent upon what is actually displayed from that return value. So you can do it that way. You can dump the username and password hashes by just selecting it from the user's table if that exists. Juice Shop, that's a login bypassing or login bypass via SQL injection. So you can do that same quote or 1 equals 1 dash dash and then a space at the end. There's also the general tautology test for any suspected injectable fields. So there's many different ways, and these are just a very small sample of what you can do. There is a program out there, SQL Map, which will automate the discovery and exploitation of SQL injection. So you can use that, and it will go through lots of different ways of kind of exploiting it and trying to do stuff. Cross-site scripting. And this is where you can inject attacker-controlled scripts into a page that other users then load and execute in their own browser session. So typically, like if it's a reflected cross-site scripting, then the payload is part of that particular request. So the URL parameter is echoed back in the response. And so this would require tricking a victim into clicking a crafted link. There's stored cross-site scripting where the payload is saved server-side. So I do remember seeing this many, many years ago where I think it was Sears.com had a stored cross-site scripting vulnerability where people could leave a comment, and when they crafted their comment a specific way, then any victim who happened to go to that web page and load the comment, well, it would change their page automatically. So it's all because of input validation. There's also the DOM-based cross-site scripting. So this exists in the client-side JavaScript, and it doesn't even touch the server, but there's many ways of getting it to be triggered. So you can also practice this, and again, the DVWA, there are cross-site scripting challenges in there, and I would definitely encourage you to play around with those and exploit it, but you can have the basic proof of concept. Any input field, you can just say script alert XSS script, and so if that's like a comment, that gets posted, and then if somebody visits that, then it will pop up and say XSS. There's the cookie that you can have it displayed. You can bypass a naive filter by just changing the capitalization of script. You can do an image tag based payload, which may get past any filters that are blocking the scripts. Juice Shop, there's the DOM XSS challenge in the search bar where you can pass that in there, and it will bypass whatever is there as part of that, and it becomes available to other clients trying to use it. So cross-site scripting is really bad because, I mean, attackers can get session cookies, there's key logging, and really it's not happening on the server side, it's happening on the client side. So it's a little bit harder to detect after the fact. There's also insecure direct object reference, which is an access control failure where the app checks that you're logged in, but never checks that you're allowed to see a specific object. So for instance, you're logged in as user ID 104, viewing your invoice, and then you just change the invoice number and you see it. It's as simple as that at times. Sometimes there are a couple of additional steps which are needed for it. So you may need to pass in your cookie, but depending upon how the system validates it, you may be able to just iterate through directories or numbers, and it just treats you as authenticated. This is one of those problems that AT&T had back in the day with, I believe it was the first iPad that was released. And they had you could go to their website and you could look up your information for iPads, because at that time, the iPads were, there was an agreement between Apple and AT&T that only AT&T was the authorized wireless vendor for iPads and iPhones. And so if you had an AT&T account with an iPhone, then you could log in and it would pull up your particular information. Well, there was an attacker out there who noticed that if you just typed in somebody else's phone number in the GET request, you got their information. And in fact, as long as you were authenticated, you could get anybody's information if they had an iPhone or an iPad at that time, and it was just this insecure direct object reference. And so he was able to iterate through all the phone numbers and get quite a bit of sensitive information just by trying different phone numbers in the particular request. So it's something that developers need to look out for, make sure that just because somebody is authenticated doesn't mean that they should be able to access everything. There should be an extra layer of security and authentication or checking for that. So finding those, there is a program out there called Burp Suite, which will let you just kind of automate this. There's a lot of other tools out there, and you don't need to use Burp Suite, but Burp Suite is a program out there which just automates it quite a bit. So you can identify the object reference by intercepting that traffic. You can note the numeric or predictable IDs and URLs, JSON bodies, hidden fields, capture a baseline request, confirm you get a 200 request with the data, which means that everything went okay. Then you modify the ID and send, and you keep doing it. Then you test it with a second account, lower privilege test user in a separate browser, confirm it's not a fluke, document the exact request, the steps to reproduce that, and that all goes into a write-up. So SQL injection versus cross-site scripting versus insecure direct object references. SQL injection is attacking the database or the server. Cross-site scripting is other users' browsers, and IDOR is just the access control logic. Again, SQL injection is unsanitized input. Cross-site scripting is unsanitized input, and IDOR is ownership checks missing. Typical fix, parameterized queries. You want to sanitize your input for cross-site scripting. There's the output encoding. IDOR is server size auth-z checks. The OWASP top 10 category for SQL injection, it's injection, which is A05. Cross-site scripting is also injection, A05. And IDOR is the broken access control, which is A01. And then there are tools out there. So SQL injection, you can use SQL map. You can also use manual testing. Cross-site scripting, you can use Burp Suite as well. Same with the IDOR, you can use Burp Suite. There's manual IDs. I've written scripts to test this as well. In fact, once you know what the sequence is, it's as easy as writing a one-line bash script to iterate through all the possible combinations. So takeaways, again, DVWA or damn vulnerable web application and Juice Shop, those are intentionally vulnerable. Don't ever put them on the public internet. Otherwise, they will get compromised really quickly. They are installed in Metasploitable 2 by default. There is a change that has to happen on one of the configurations on that, and that's detailed in the homework 2 that you will end up doing, but you just have to specify the database name. SQL injection happens when user input is just passed directly into a SQL query. Cross-site scripting has various flavors of it. where stored cross-site scripting is the most dangerous since there doesn't need to be any interaction. Indirect or insecure direct object reference is an authorization failure, not an authentication failure. So it's just changing different names and numbers and all sorts of other stuff. And they map to the OWASP top 10 categories. And the consistent methodology is you establish a baseline request, tamper with the input, and just keep iterating through that.